All right, everyone, welcome. Excited today to get to talk about insulation and air sealing, topics that I find really interesting. The more I've worked in construction, the more I've gotten to see what happens when things aren't quite right with these and how to fix them. So it's really nice. There's some really great resources out these days, and you'll see I have a nice handout from the North American Insulation Manufacturers Association, which has a lot of pictures on how to do things correctly and how sometimes they're not done correctly, to make it really easy for us to explain to folks in the field how to do things to our trade partners. And I'm also excited because Michelle Griffith is here from DeVere Insulation. Thanks for coming in.
No problem.
Michelle runs the home performance division at DeVere. They're the ones who come in and do retrofits on remodels, which, as you guys know, we often do for our clients. You can take a mediocre house that was built a couple decades ago and is leaky and uncomfortable, and with her crews we can upgrade the whole thing and make it much more comfortable for the clients, which is a really sensible upgrade if you're going to, if we're working in luxury houses, right? Our clients want to be comfortable, and this is a really great way to get it done. So she'll be here with ready to answer questions for us on anything that comes up.
Sounds good.
Thank you. Okay, so here's what we'll cover today. I want to talk about sort of some of these issues, as I mentioned, and some of the more interesting and complex problems that clients have asked us to solve on their existing houses involve insulation and air sealing. What is an air barrier, quality spray foam and fibrous insulation, and some of the framing details that we need to do to make it easy for the insulators to do a good job for us. So let's talk about some of these issues. So we're a remodeling company. We work in a lot of older existing houses. A lot of times we come to these houses and they have some serious comfort complaints. So here's an example of a house. These folks said this is kind of the middle of the house, although the house has been added onto several times. It's really cold here at the kitchen island. It's like there's cold air coming out of the ceiling lights. So we took out the thermal camera, and sure enough, you can see the yellow parts are things that are sort of at normal room temperature, and the dark blue are things that are almost at wintertime outside air temperature. So yeah, there was tons of cold air moving through these soffits, and what had happened is, as the process of adding these additions went on, people didn't make good air barriers between the outside and the inside, and the air was able to travel through these soffits and pour onto the kitchen counter in this multi-million-dollar house. So that was a good find and a good thing for us to be able to fix. Comfort and air sealing issues tend to be some of the ones that we find. Another thing that happens in our area is we have pretty wide differences in humidity, right? In the middle of winter, very, very dry outside. In the middle of summer, very humid outside. And it can be uncomfortable if the air inside your house is dry. It can be uncomfortable if the air inside your house is very humid. So let me just point out this somewhat obtuse graph is a temperature and humidity recording inside a building during about a 1-week period towards the end of winter. And this is 20% humidity level. So you can see at times the air inside this, it's actually a condo, was below 20% relative humidity. And then this is 60% relative humidity. So within a week, we went from a cold snap to a warm snap, and all of a sudden we had indoor air humidity above 60%, well into the uncomfortable range. So that's not good for the clients. But one other important thing about most of our houses, they're full of wood, right? So what happens to wood when you keep it in 20% relative humidity? It shrinks. Yeah. How about when you put it in 60% relative humidity? It swells up, right? Moisture goes into it, it gets bigger. So if you move wood around enough, you can get yourself in trouble. In fact, in this particular condo, they had a floor that was made with, it's a plywood floor really, right? So the top is a piece of maple about 1/8 inch thick, and then it has pieces of plywood underneath it that's all glued together. But when we put it in those conditions, it actually pulled itself apart. So it was just too much of a range for this particular product. So if you can't control the airflow in and out of your building, you'll get outdoor winter humidity levels in the winter and outdoor summer humidity levels in the summer. It's not going to work for the clients or for the wood. This is a house that has one of these so-called mansard roofs, That's where the sidewall is actually a roof, right? So there's this sort of triangular space behind the vertical wall inside the room. And in this one, the clients called us because they were having some weird things happen. Mildew around their electrical outlets, even water drips running down from the outlet. You can see it on the cover here and then on the drywall. So we tried to figure out what was going on. They also had this cabinet, and there was sort of mildew on the bottom shelf inside the cabinet. So it turns out that there was just too much air moving from the outside through that mansard area and through the insulation. And the reason is the vertical wall didn't have an air barrier on the outside. The bats were just installed in the wall. So if you opened up the roof, which we actually did, you were looking at the back side of the fuzzy insulation. Now in this picture, we're already starting to cover that with an air barrier. But because you're looking at the insulation from the attic side of that wall, the insulation doesn't really block air. I mean, this is one of the things that I've seen over and over. The fiberglass insulation allows air to go right through it. So if you have an electrical outlet that's only blocked by fiberglass insulation on the backside, air will go right through that electrical outlet. So what happened was in the summer, that humid air was going through the electrical outlet, hitting the cold side on the inside of the wall, and turning into water and dripping down the wall. And the home audio guys had helpfully drilled a bunch of holes in the back of the cabinet. So that just really magnified how much air would go through the cabinet from the outside. That's where the mildew came from. So we fixed it by putting in air barriers and covering up all that insulation. Another thing that we see a lot in summertime around here, we get clients who will call and say, oh, I've got water dripping off of my air conditioner outlet. There must be a leak somewhere. Can you come see what's going on? So this is an example. Came into this room, and that register is right over here. And there was a leak, but the leak was of humid air coming through the French door down here. Because this was one of those fancy doors where you have to lift the handle up to actually seal the weather stripping, and they didn't know that, so they were just slamming the door, and it really wasn't shut. So a lot of humid air would come in, float up to the ceiling, and condense on that cold register. Sometimes we find condensation on ductwork. On this particular ductwork, it's actually in a garage, which is a terrible idea. Someone built a house that had ductwork in the garage, and you can see it's 50% relative humidity in the garage. So the ductwork is well below the dew point. That humid air hits the cold ductwork, and it just starts to rain. Here's some more wet ductwork up in sort of a half attic Cape Cod type thing where there's a little room next to the real room that's sort of in the space and sort of outside. We used the blower door to test this house. 10,000 cubic feet per minute of leakage at 50 pascals. That's a very high leakage rate. So when we used the thermal camera to see where the hot air was leaking in, we looked in this sort of weird place where there's insulation with no air barrier on it. And sure enough, you can see the yellow warm temperature where the hot air is leaking through the insulation into the space. And that hot, humid air is what's causing the condensation on the ductwork. So there's another area, similar situation. Very hot, outdoor temperature air leaking through because there's no air barrier. So the people who had built this just didn't cover the inside of this space with drywall or anything. They just hoped the insulation would keep the air out, and it really doesn't. Another situation with condensation on a register. This one, there's no windows or doors in the room. There's a fixed window, so that's not leaking very much air. So we couldn't figure out where it was. We're poking around in the attic looking to see if there's some sort of hole or something going on around the register. But there's a wire going over to the cabinet, and sure enough, there's some lighting above the cabinet. Now, how do electricians make a hole for the wire for the lighting above the cabinet? With a hammer, right? They're going to put a hole in the drywall with a hammer. Big hole. So you can see the hot air leaking in, and sure enough, right here, there's the big hole where the wire comes through, where they poked a hole into the attic. So there's hot air, humid air from the attic directly coming in right near the vent. Another interesting situation in a house we had, this room is in the middle of the house, no windows or doors at all, but they always kept getting mildew around the exhaust fan. So obviously exhaust fans do connect to the outside, There's supposed to be dampers in them, but not necessarily all the best dampers. But what could cause air to move backwards through from the outside through a fan? You'd have to have some kind of force pulling it, right? So one thing that's interesting about a lot of our houses, they're big, they're complex. If they have a lot of air leakage in one place, where air can leave the house, it can often pull air in through all kinds of random other places and cause weird problems. So this is another reason why when we go to remodel an older house, it's a really nice idea to do as much air sealing as we can. We can prevent the air from leaking in random places like around this fan, which we were able to use some diagnostic tools, check where the air was coming from. Sure enough, it was some of it was coming down the joist bay. We blocked off the joist bay, and some of it was coming through the ductwork. We put another damper on it, and but a real solution for that house would have been to do duct sealing in the attic and to have done a much better overall air sealing package while we were renovating it. So it's one of these things where I'm not sure clients understand the value, but if you have a leaky house, you'll have all kinds of weird problems. So it's really helpful if we can get them to do that stuff. Another sort of classic example of a comfort issue is my bathtub is freezing cold in winter. Can you fix that? Well, in this case, it was pretty easy. It was nice. We should all remember this. This is a removable panel. So easy to get to the motor on this Whirlpool tub and to look past the motor and see the uncovered fiberglass insulation that's allowing outdoor air to leak through. So, every wall will leak a little bit unless it's very thoroughly sealed. And if you have nothing at all on the inside, it will go right through the fiberglass and come into the area, in this case under the tub, make the tub freezing cold. We've even seen frozen pipes in situations like this where the insulation isn't covered. So all these are interesting and complex issues. Air leakage can cause humidity problems, can cause comfort problems. Insulation that's installed incorrectly can cause comfort issues. And a lot of these problems can be among the more challenging to fix. So it's much better if we can nail them up ahead of time and get stuff installed correctly. Okay, so I've mentioned air sealing a few times, and I've mentioned that fiberglass does not really block airflow. So one great analogy for this is if you were to go outside when it's 15 degrees and windy, and you just had on a sweater, how do you think that would feel? Would the wind kind of feel cold, right? The wind would go right through the sweater, right? So maybe not a sweater. Okay, so what if you brought like one of those shells? It's just a thin layer of windproof fabric. Instead of the sweater, you put on the shell, and you go outside. Well, probably you block the wind, but it'll be cold, right? There's no insulating value to just the shell. So for a house, we really want both. We want like a parka, one that has insulation and blocks the wind. So when we build a house, we can't just buy a parka. We have to put together both the outer shell and the insulation and the inner shell. Good little metaphor, I like that one. So how do we do that? In new construction, when we have all the cavities open, we can work on it. 3 different ways I can think of off the top of my head: spray foam, manual air sealing, and kind of taping the sheathing approach. So let's talk about that. We do this on a fair number of jobs. If you fill the cavities with spray foam does air seal. So that's a good air seal like that. And there's another approach called flash and bat, where we do a relatively thin layer of spray foam and then we fill it with fibrous insulation. In this case, we're using a wet spray fiberglass, but you can see that the cavity isn't filled with the spray foam. But we added, in this case, we had 2 inches of spray foam, which does a combination of air sealing and some of the insulation. And we always want to do at least 1.5 inches for condensation control. Just to remember, some trade contractors around here will try to sell you 1 inch of spray foam for flash and bat, but in our opinion, it's not enough. So that's another approach. The spray foam, if done properly, does a pretty good job of air sealing. You can actually manually air seal sheathing cavities, framing cavities. The sheathing itself is usually fairly airtight. It's around the edges and the joints and the perimeter. So if you go around and seal all of those joints with spray foam, you can, or caulking or anything, you can get a pretty good air seal. One of the issues with this approach is on our complex houses, there's all these little things like this big post, big hole in the framing. So how are you going to air seal that, right? You can't just caulk that. Or there's a cantilever that's open. So it's an approach that can work. In fact, DeVere uses a system called Energy Complete that's made by Owens Corning, and it's actually a really neat system. It uses a special sealant that remains flexible, so it makes a kind of a gasket. So when you put it on the face of all the perimeter of a wall, the face of the studs and the top plates, when the drywallers push the drywall up against it, it stays, it makes a gasket, so air can't leak between the drywall and the studs. So that's a pretty cool system, and you can see they also do the perimeter of the window, and they do the joints and the sheathing. So it's a really neat product. It costs a lot less than spray foam and doesn't have some of the spray foam's downsides. So that's another approach to a sort of manual air sealing. You can also try sealing the drywall. So this is actually in our trade standard for drywall, is to put adhesive, a complete bead of adhesive, particularly across the top plate, but also around all the perimeter of the wall, sort of the same way that you would with the Energy Complete. And that can stop air from flowing between the drywall and the studs. So that's good. As I mentioned, you can tape the sheathing. This is an approach you'll see on some of our jobs and a lot of new homes that have to be blower door tested. It's actually very effective. If you seal the sheathing to the foundation and you cap off the top of the wall so it's not leaking and tape all the joints, very little air will move through the walls. You still have a lot of other parts of the building to air seal, but it's great for walls. So let's talk a bit about retrofits, some basic pictures of where air leaks out of older houses. One of the key points in an older house is the tops of all the walls where they hit the attic. As I mentioned, fiberglass does not block airflow. Actually, one cool feature of fiberglass is it will filter air filter dust out of the airflow. So if you have an air leak, you can tell when you're looking at old fiberglass because it turns a different color, right? It turns black from all the dust that's filtered out of the air. So, as we know, the top of every wall has a top plate, right? It's a 2x4 that's parallel to the wall. And when that wood shrinks after it's installed, there gets to be a little crack on either side of it between the wood and the drywall, or in this case, plaster. So that little crack will leak a little bit of air. And in this picture, you can see how much darker the insulation has gotten from 20 years of air leaking through it. This is on a job that Tom did. And when we pulled down the top plate, you could just see this black streak right on each side of the top plate. So this is a house we actually did a retrofit on. And the way you fix this is you go up in the attic, move the insulation out of the way, and seal the joint between the drywall and the top plate. And just by doing that and finding the other holes in the attic ceiling, so around electrical boxes, wire penetrations, can lights, you can make a huge difference in the comfort and efficiency of a house. So this is what your crews are experts at. So we've had really good success with this. I know at my own house I was able to cut my energy bills by like 10%, and went from having very dry wintertime air to having very comfortable wintertime air. Just way less draftiness, way less air exchange, much more comfortable. A lot of our houses have ducts in the attic, and it's really important to seal those. They're under pressure, so a tiny hole in a duct will leak a tremendous amount of air. But usually the same crews can handle it, or there's some other ways we can do that. So here's an example of a house. This is a very expensive luxury house we were working on for some really nice folks in Bethesda. Almost a new house, only a few years old. They were uncomfortable. Their energy bills were high. There's a lot of weird stuff in this house where they had, obvious air leakage. So in this bay window area is very uncomfortable. We pulled the carpet back, drilled holes to plan to fill it with insulation. And when we did, you can kind of see it here, you could actually see light through the underside. So there was a direct connection from that floor joist cavity, which had no insulation in it, down to the outside. So we filled it up with insulation, did similar stuff like that all over the house, and we got the air leakage down from 11,000 cubic feet per minute to 6,000 cubic feet per minute, almost cut it in half. Talked to the clients at a party. I asked them, how was the house this winter? They said, oh, it's so much more comfortable, less drafts, we were warm everywhere, it's really nice. This is a really nice thing you can do to folks. All right, any questions on the air sealing? Okay. Okay, let's cover spray foam really quickly. As I mentioned, we do use this sometimes. Just try to get some quick basics out of the way. In the residential market, there's two basic types of spray foam, so-called closed cell and so-called open cell. Closed cell is it's 2 pounds per cubic foot density. It comes out pretty hard, right? It's very solid. It's pretty strong. It's actually, if you ever have to retrofit a wire through it, it can be a big hassle. It's more expensive. It has a higher R value. We sometimes use it if we have to get a high R value in a narrow cavity because it has a pretty high insulating value. And open cell is much less dense, much less expensive, and it doesn't have quite as high an R value. But the thing you get with both of these is a combination of insulation and air sealing in one product. So that's why it's a really attractive idea. It is kind of expensive though, and there are some other hassles we'll cover in a minute. So let me just jump into some of the quality issues we see with it. So the whole point of spending the extra money for spray foam is to get a good air seal, right? So one of the things that, especially in a remodel situation where we might be doing part of an area and not the whole thing, is to make sure that we cover all the air leaks. So in this picture, we're looking up at a garage ceiling, and we've sprayed the bottom of the floor above, which is a really nice way to keep the floor warm. And the guys did a really nice job. They blocked off each joist bay, and they sealed down to the top plate of the wall, which is good. You're sealing between the garage and the house. It's very important to get a good air seal there so that none of the car exhaust goes into the house. The only thing is, as you can see here, they didn't quite nail it, right? They accidentally sprayed part of this joint, but they left a big hole where air can move between the garage joist bay and the house joist bay. So we just have to make sure that the spray foam guys understand, like, we really need to seal all the way at the perimeter so that all these air pathways are blocked off. Pretty simple. One other thing that happens with spray foam is there can be voids or places where it's not very thick in the house. So the best way to check for that is with a thermal camera. When I first looked at this area, it all looked pretty good to me. You know, it looks like it's a reasonably complete spray foam job, but with the thermal camera, you can kind of see there's this spot right here, much colder than the rest of the wall. And so it turns out that this is an incomplete area. So the spray foam company comes back to fix that. If there's enough, they'll bring the truck back, but sometimes they just come back with can foam, which is perfectly fine. They just fill in any of these empty spots. So that's all good. And here's another thing that can happen. You can sometimes, this is unusual, but it does happen, especially when you're spraying onto a very cold or wet surface, which you're sort of not supposed to do, but you can get these gaps if things don't go right. So if you ever see this on a job, that's got to come out and be redone. I mean, you're not getting insulation or air sealing if it does that, so we have to make sure that that gets done correctly. One other little detail, when we spray all the way up a cathedral ceiling or enclose an attic, we're going to normally try to vent the roof. I mean, what do you get when you vent a roof? It does some good things for us, right? What are some of the advantages of a vented roof? Stays cooler, better for the shingles. I think there's been some research done. Apparently a lot of roofs get wet in heavy storms, and if you have good ventilation under it, it just dries right back out. If you block off the ventilation under it, it might be a lot harder for it to dry out. So it's a good idea to vent whenever you can. The way to do that is to just install the vent channels before you do spray foam. So you can see on the right, we've already spray foamed. On the left, we have the vent channel ready to go. So we'll always do that whenever it's feasible to make a vent channel all the way from the soffit to the ridge. Another very important point, as Joe was talking to me about, make sure your rough-ins are complete. All the wires and pipes are run. We didn't have to go put anything through this closed cell spray foam, but if we had, it'd be very challenging. You'd basically have to drill it the whole way. So let's make sure everything's done before we bring the spray foam guys in. Okay, let me talk about a couple of some sort of hassles with spray foam. One of the things is the product is being manufactured on site. Right? You're mixing chemicals together. This chemical is not that good for you. This chemical is not that good for you. As long as they mix together perfectly, it turns into another product that is okay for you. But if you end up with excess of one or the other, it can be bad for you. Also, when they're spraying it, there's all kinds of stuff going around that we shouldn't be breathing. Everyone in the room is supposed to have a supplied air respirator and face protection. So that means that we can't be on site while that's going on. Our clients can't be on site while that's going on. Our tradespeople can't be on site while that's going on, and we should really wait at least 24 hours, and with some manufacturers, it's longer than that. So this can be a little bit of a schedule hassle, right? If we spray foam on Monday, and we have to come look at it with the thermal camera on Tuesday and have them come back and fix it, they're going to have to come back on Wednesday, so we can't schedule the drywall till Thursday. All right, so we need this 48-hour period after the spray foam is done just for quality checking. So that's a schedule hassle. There's some worse hassles. Fortunately, this is rare, but as I said, you're mixing these chemicals together. If you don't get exactly 50% of each, you can have an excess of one that stays in the foam and evaporates off into the house over a long period of time. Everything has to go right inside the gun nozzle. That's a little bit complex. They actually literally wear out, so that has to be done just right. The temperature has to be just right. If anything goes wrong with any of these things, you can end up with chemicals off-gassing into the house. So that's not very good. It is extremely rare. It doesn't happen very often, but you want to make sure that it doesn't on our jobs. So I think it's kind of risky. Go ahead, Larry.
Are there tests for that to know if
Yes.
there's...
So depending on each company probably does things differently, but at DeVere there are lots of different gauges there's about 5 different gauges that are on the machines that are built onto the trucks. So that way if it goes off ratio, it actually shuts the machine down.
Yeah, this is one of the reasons it's good to have a good partner like DeVere with well-trained people and good equipment. So
Is there anything that a week or two later we could bring to the house that would let us know if there's any gases?
There is, but it involves a very expensive industrial hygienist. So.
And if there is continuous off-gassing, the smell is very prominent, so you'll know that something's not right. Also, you can tell because the foam will remain sticky and tacky. So if you ever have a spray foam after 12 hours that is even remotely sticky or tacky, that means that the ratio was off. The spray foam crews actually should be also, they have a scale that they should be weighing the foam with to make sure that the weight is the exact weight that it's supposed to be, because that's another check that they can do.
There you go. So the question was, can we test it right after? You can't really, it's hard to test for the gases in the air, but there are other things you can do, obviously. Yeah. Another issue that's important to know about is if you spray enough spray foam into one place, the heat of the curing process can actually cause the foam to be damaged or even catch on fire. So this has actually happened on some houses. The key point here is if you're spraying closed cell insulation, you spray it in 2-inch thick layers and you wait about an hour before you come back and spray another layer. So that's another potential scheduling thing. If we're going to do a 6 or 8-inch deep installation, that takes all day. But it's just important to know this. Both of these issues with the off ratio and the spraying the wrong amount, spraying too much at once, I feel like the industry's really come together. They have education programs, and you don't see crews accidentally spraying 6 inches of closed cell anymore. But we need to know this and make sure that doesn't happen. Again, a somewhat risky product. Any questions on spray foam? Okay. Okay, cool. Let's get into the important part of this. We mostly use fiber insulation for reasons of cost and safety and hassle. So we're going to ask for what's called a grade 1 installation quality. That's the top level. That means everything is done just about perfectly on the installation. And there's a guidebook, which everyone who has a project manager's resource book, I have a copy for you. So we'll hand those out too. Let's start with the number one thing. Because insulation, fibrous insulation, and this includes cellulose and rock wool as well as fiberglass, because it's not an air barrier, you need to enclose it on an air barrier on all 6 sides, and if you're in a vertical application, or it really won't work as insulation. You'll just get convective currents going through it, moving through it, and taking all the insulation value away. So it's important that we have air barriers everywhere. Obviously, in a regular exterior wall, that's no problem, but there are parts of the house we build, like if you have an attic and you have a knee wall, sometimes we don't sheathe the back of that for any structural reason, but we need to if we're going to use fibrous insulation. We need to put a backing on that wall so that the insulation is enclosed on all sides. quick note, attic floors, it's okay that it's only enclosed on one side, that it's open on one of the sides. And on rim joists, in our climate, it's not a big deal that there's no air barrier on the inside of a rim joist insulation. But everywhere else, we want to enclose it on all 6 sides. So let's talk about some of these quality points. The difference between a grade 1 and a terrible installation, one of the main things is that the insulation should be touching the air barrier on all sides and completely fill the cavity. So in this picture on the left, you can see it's not going to touch the drywall ceiling when we attach it. There'll be big gaps between the drywall and the bottom of the insulation. Whereas the one on the right, it's completely full. The drywall will be touching the insulation the whole way. You can't have air blowing through it as easily. Same thing with a small cavity. Sometimes see this, you have a 2.5-inch cavity and the installer cuts maybe a 4-inch piece and kind of jams it in there. Then there'll be a big space between the face of the insulation and the drywall. Instead of that, we want to do what's on the right here, cut the piece the right size and have it completely fill the cavity out flush with the drywall. Same thing here. Just do a nice neat job so it's all flush out to the face of the cavity. On the left, they've kind of tucked the bat behind the wires in this conduit. And on the right, they've shown how they actually split the bat in 2 pieces, put one behind it and one in front. You're supposed to do it that way where it's split around any wires or pipes. Here's some electrical box stuff in the way. You have to cut it's hard to do a neat job, but that's the difference between a good job and a mediocre job. So we want to do a grade 1 like on the right. Sometimes the paper can actually more or less get in the way of having the insulation touch the back of the drywall, so the paper has to be cut to the correct width. And actually, let me just jump into this. What kind of facers do we want to use? Well, in our climate, you don't need any facing on insulation. So you can use unfaced bats. You can actually, it's important that we not use anything that doesn't allow moisture to go through in both directions. So we never want to see plastic or foil unless it's perforated. So that's very simple. So really what it comes down to is either unfaced or craft-faced bats is what we want. There's another thing called a smart membrane. I haven't ever seen it around here. Technically, it's okay. But unfaced or craft-faced is what we're looking at. And you don't need to staple the insulation in place, except in places where it'll literally fall out. That's the only reason you need to staple it. So in most 2x4 or 2x6 walls, you can leave the stapling flanges folded over and not staple them to the wall. There's no need to staple them. In a lot of ceilings, you have to staple the bats in place or they'll fall down. But you want to minimize how far up that staple is. You want to have it very close to the edge of the 2x4 so there's not much airspace between the bat, even at the very corner. So that's bat facing. Oh yeah, this should go without saying. In this room, this goes without saying. The bat, if you have a facer on the bat, it faces the warm side in winter. Every once in a while, you find someone who does that wrong. Okay, so let's look at some more of these things. Complete fill around any obstacles in the ceiling. Got to go tight to the ceiling lights and fill in all around, which can be a fair amount of work. Those are pretty complicated shape. If you have wires in the ceiling, you split it around those. I see this a lot actually. Bath fans, it's a little bit complex to get the insulation all the way around the duct and the box and the wires, but we got to do that. This just looks like someone was feeling lazy, left a big space. If there's a pipe that's near, you have to split the bat around the pipe. And same thing with the wires. Okay, let's play a little game here. This is an actual installation that we had to have a quality control revisit on. What's wrong with that installation?
It's not running light.
Yeah, there's a giant hole through it. Not going to insulate very well, is it? How about over here? See how far the edge of the bat is from the corner of the drop ceiling? Yeah, so they needed to cut that a little narrower to fit in there. We'll find this on a lot of renovation jobs. So you can see on this project we had old joists and we sistered next to them, so the cavities are the wrong size. It's a fair amount of work to trim each bat to fit it, but that has to be done. All right, how about here? Yeah, good one. Big gaps where it doesn't go over the plate. And then how about down here, the wall? It seems like there's it's pushed way back in there. Yeah, those need to be fluffed out so they're flush with the drywall. What's that? The framing isn't stacked, yeah. Big mistake there. forgot to call the framer on that. These are actually unstapled bats, so they're bats that have a craft face, but they don't have a staple flange, which is perfectly fine. They just fit in by friction. As I said, unfaced or craft face. All right, any questions about how to do a grade 1 fibrous installation? All right. Okay, so we'll hand out those guidebooks. A lot of those pictures came from that guidebook, are really helpful. All right, let's cover a couple other quick details here. One thing that's important at the perimeter of an attic is to prevent air from blowing in the soffit and then just going right under the insulation across the ceiling. So we want to install what's called baffles. They're just pieces of cardboard. They fit down onto the top plate. Fit down onto the top plate, and then they cover the edge of the insulation. And you want it to be pretty thick so you get full depth insulation over the top plate. And then you have a vent cavity at the top that connects down to the soffit so the ventilation air can still come in. Very simple, as long as you do it. On a cathedral ceiling, we want to use these vent channels. So if we have insulation running all the way up the rafters, we want to make sure a vent cavity is left above the bats. So we're going to use these vent channels the whole way. And I think did I read the maximum space between those is a 1/2 inch?
Yes.
Right. So they have to be very close to each other. Every once in a while you see someone space them out, 6 inches or a foot, but the insulation will push up in there and block the airflow. Tell us about this attic stair cover.
So
It's up here.
you have a couple different panels there. So your push-up attic covers, you can't use one of the pull-down attic stair covers on, but if you have an attic stair that you pull down, instead of just putting a piece of bat insulation on top of it, you can actually use a batic cover, which basically seals from the inside, and when the customer pulls down, they'll see a silver lining, but it's 100% air sealed. So that's actually a huge penetration if you're trying to achieve some type of energy reduction or blower door number. That will really impact that. And it also stops the radiant heat from building up in that area as well and reflects it back off of it. So customers tend to definitely prefer that over the bat insulation, as well as when you pull down the attic stair, you tend to have some fibers that want to come down with it. So in this case, it stops the draw from the fibers and allows the customer to just unzipper it and push it up to get into the attic. And then the same thing with your attic hatch that you basically, piece of drywall you push up to get into the attic. A lot of times you'll see a piece of bat insulation that definitely deteriorates and gets messed up over time. What we typically do is we'll take 6 to 8 inches of 2-inch foam board, create a barrier on the backside, as well as also weather strip the trim, so that way when that piece of drywall sits into place, it's sealed properly.
All right. Yeah, I like that zipper attic door. I think our clients would really prefer that to having the fiberglass land in their hair. Seems like a good idea. Okay, one other quick detail. Even the Fiberglass Industry Association says don't seal your windows with fiberglass. You should use foam or caulking to seal the windows because they're airtight and the fiberglass isn't. Any questions on any of those? Okay. So as I mentioned, there's a few things that we need to manage on the framing side to make sure that things are ready for having proper air barriers and installation of the insulation. So we have to know where those are. We got to be ready to block off joists in the right places, and there's some details about how walls are framed that can make it much easier or much harder to insulate. So we'll talk about those. First of all, on bathtubs, you can see this is a tub-mounted deck. We're kind of looking at the exterior wall. You can see when that deck was already installed when the drywallers arrived, right? They notched the drywall around it, and the drywall does not cover the inside face of the wall under the tub deck. But if you're Charlie and Alex, you put OSB behind the tub deck before you attach it to the wall. So there is a complete air barrier there, and our air barrier is intact under the tub. You won't get cold air blowing through the insulation in winter. So that's the first thing to do. If you're building a deck, you can use OSB. If you have a tub that's attaching more or less directly to the wall, like a regular wall mount tub, you can use something thinner like thermoply or masonite. Just seal it to the floor and the perimeter. You can extend it up above the tub for the tub finishes to connect to. Then you get a full air barrier behind it. So that's something we obviously have to get the insulation and the air barrier installed way before drywall, like like during the rough-in phase. So that's something to keep an eye on. Another area is the area behind a metal fireplace and a framed cavity. So, what's wrong with this area? I'm standing looking where there used to be a fireplace where we took it out, we're putting in a new one. How's this insulation and air barrier setup going to work? Pretty good? You can see the sheathing directly through where there's no insulation. So we want to fill that with a good installation job, and then we also want to add an air barrier all the way up that to protect that insulation and make it actually work. So you can see we're going to put a sheet good across the inside face of the studs. Gypsum board is actually great for this because gypsum board performs reasonably well in a fire situation, so that might be a good option. I see thermoply and OSB used a lot too. Those are okay. Here you go. So you can see all the insulation's covered back in there. We get a lot of comfort complaints on older houses with these. Somehow they seem to leak a lot of air. I think a lot of, maybe people don't wrap them with house wrap in the old days. They think the firebox is out of the house, but it actually connects to the house pretty well. So if you don't insulate and air seal that pretty well, you're going to have cold air coming in, and people seem to not like the cold air. Okay, the classic spot where we have to help. Go ahead.
How would you retrofit that if you're not replacing the firebox?
How would you retrofit that if you're not replacing the firebox? That's actually really challenging. I know. Let's see. Did Charlie make it in today? He's working out west. Yeah, we've had a couple of jobs like that where we're not intending to do anything, and there was one that we did, and I said, I'm not sure. I think maybe you could go around the outside and try to caulk any visible joints or places where air could be leaking. And we went around it, and someone had smeared like 6 tubes of caulk all over the outside of this thing already, and it was still leaking really badly. And I think it was coming in around the cap or the flue. There may not be a good answer, is the short story. You just do anything you can find is the best you can do. You can't really fill it with insulation like you can. There is the approach of just packing in a bunch of cellulose insulation. You can fix fairly large cavities that way. If you get enough cellulose in it, packed densely enough, it will reduce the airflow. But you can't do that around a fireplace. So there's no good answer there. Go ahead, Emma.
Roxol instead, that fulfills your fire.
Can you use Roxol instead?
Use Roxol instead.
Well, if you read the books on these manufactured fireplaces, there has to be an airspace around them. So without really getting inside the space to rework it, you can't just fill it all full of insulation. Yeah. But you're right, Roxol's pretty good against fire. Yeah. Okay, so attic knee walls are kind of the typical situation where if we don't add an air barrier on all 6 sides of each of these cavities, we're going to have a real problem with the insulation and the air leaking. So this is how this is what we do. We just put some kind of rigid sheet good on the back side of the wall. Pretty straightforward. I see a lot of people using thermoply for this because it's so easy to work with and inexpensive. You can use OSB, drywall. Foam board, a little bit questionable because of fire code issues, but there are foam boards you can use that have special facers. So this is what it looks like looking down from the level below. You can see the thermoply running up the attic room's wall. And I like this picture because they actually did a really nice job. They put blocks in between each joist bay, and that blocks air from flowing back and forth under the floor. So that's another thing we're going to do in one of these attic spaces. Make sure we block that all off. All right, so here's some knee wall areas. Anything wrong with this? Yeah, it's just perfect. Yeah, we air stopped 90% of it. So obviously it's got to be complete, and you have to seal the joints. How about here? This framer decided not to use a top plate in this assembly, so we need to add the top plate if we got to enclose it on all sides. How about here? No bottom plate. So you would have thought it might have been obvious to say you need a bottom and top plate, but you don't. You do have to say it because sometimes there's some reason, probably a good reason, why they didn't do that. But if we want the insulation to work, we got to enclose it on all sides. All right, how about a skylight shaft? It's kind of an attic knee wall on all 4 sides, right? But with lots of extra framing in the way, and it's kind of hard to get around outside to do sheathing. So, if you want to enclose the insulation on 6 sides, you could in theory, sheathe the outside of it and then have spaces that you fully insulate and then have the drywall on the inside. But that's kind of a pain. So Michelle actually brought a really neat product they have for that.
So we actually, we have 2 applications typically that we do for these, and a lot of it depends on the room that you have to move around. So sometimes with skylight shafts, we'll wrap it with bad insulation if it's a 2x4, and then we'll use an air barrier over top of it. We'll seal all the seams and foam, you know, all the edges. Or if you get into a tight space, or a lot of times in older houses, you'll see the 2x4 laid flat, so there's only about 2 inches of space. We'll just spray a closed cell foam all the way around it to encase it.
There you go, and that's called Skyflex. That
Skyflex.
material? Right. So that's a
So this is an air barrier,
barrier.
but not a vapor barrier.
That's a pretty neat idea. We actually were just scratching our heads about that a couple weeks ago on a job.
We also use this a lot on knee walls. So we'll put insulation in the knee wall, and then we'll use the air barrier on the back side of the knee wall, and then tape and seal all the seams.
As long as it's taped and sealed, that should work great. Interior soffits are another thing. You know, what I mean by a soffit is kind of like this sort of thing, a little chase that runs along between the wall and the ceiling. So we know we have to fire block that, right? It says right in code, you can't have a connection between the wall cavities and the ceiling. So you have to block off either the side or the top of it so that air can't go from the wall into the ceiling. But if you really want to do a good job with the air sealing and get the insulation to work correctly, you should really cover both the side and the top, because if you just lay bats over the open top of the soffit, a lot of air can leak through there. And there's usually a bunch of connections through the soffit, like, you know, ceiling lights, or there's some ductwork in there. So here's some pictures of how to manage that. One of the things you can do is just put a sheet good up on the ceiling before you start building the soffit. Very straightforward. You can even use drywall and extend it out into the room, and then the sheet rockers will just connect to it later, and you have a continuous barrier. You do want to seal the joints, so in this example they used thermoply on the left, but they didn't seal it, and on the right they did seal it all up with can foam. So that's much better if you can do the top and the sides, but you definitely have to do one, because otherwise you haven't even met code. Okay. Double walls, another interesting situation that happens to us every once in a while. I mean, we're doing a job right now where, more for aesthetic reasons than anything else, we actually have 2 studs. It's almost 12 inches deep. So how do you insulate that? Well, if you just put insulation to the outside, then you'll have this big air space where you can have air circulating through. There's no air barrier in contact with the insulation. The short answer is here on the bottom, just fill the whole thing all the way from the outside to the inside. Fill the whole thing up with insulation. That's one thing you can do. Another thing you can do is build the first wall, insulate it and put up an air barrier material like foam board or thermoply, and then build the second wall and insulate that. And then you have insulation in the whole way. In fact, I would say that the second thing is the way, if we have to build a shower or some other plumbing thing on an outside wall, build the regular outside wall, insulate it, cover it with a well-sealed air barrier, then build an inner wall and put the plumbing in that. And then you don't have to worry about it freezing and all the air leak and all the problems. Okay, so I mentioned we got to block off floor joists in certain places. Here we are outside of an attic room looking at a well-sealed wall. This is the knee wall. Really good sealing job. And each of these bays has been blocked off. So very nice work there. I think that came from your presentation. This is one of the jobs our crew did. So that stops air from blowing underneath the room and making the floor cold. Very important to do this at garages. If you have joists that cross over the wall into the garage, I mean, you really don't want carbon monoxide from your car leaking into your house. So you want to make sure we fully block and air seal above that wall. Make sure the joist bays are totally blocked off, including any penetrations. And with I-joists, of course, you have those it's hard to block into the web, so you got to either use can foam or spray foam or something like that. So floor over unconditioned space, this has traditionally been a head scratcher for us. I mean, let me just skip to this slide. This is what they usually look like when we find them, right? We go into someone's crawl space and all the insulation's falling down. Half of it's on the floor, the other half is dangling down. Or even if it's neatly installed, and there's maybe a ceiling under it, the bat is now sitting on the drywall below, and there's a 4-inch space above. And so everything is, there's just air blowing back and forth under the floor is uncomfortable. So what we want to do, this picture on the right shows tiger teeth holding up the insulation. If that worked, it'd be great. I mean, one thing you can see in this picture is they stuck those things in like every 16 inches on center. I think the instructions say like 12 inches on center. And then when you go to someone's crawl space, they're installed like 3 feet on center. So, basically those are not really a permanent way to hold the insulation up against it. And what we do instead is we fill the whole cavity with fibrous insulation. So we're either going to use a thicker bat, or we'll use 2 layers of bats so that we can get all the way full. And that way it can't really fall down. If you already have drywall on, you can blow it full of cellulose. That works great. And one thing we do use a fair amount of spray foam on these. The spray foam will stay stuck to the floor above, so that's a pretty good start. Especially if there's no drywall, that really might be the way to go, because there's nothing to really hold that bat up. Spray foam might be the way to go. And make sure the paper's facing the right way. Again, I have actually seen that. Okay, cantilever's a special example of a floor. One of the key things with cantilevers is it's very hard to air seal the whole bottom and the perimeter of a cantilever, especially because a lot of the work's going to be done by a trim carpenter who's probably more of a production person who doesn't know anything about air sealing. So the best way to address that is to just completely block off all the joist bays above the wall, above the interior wall. So there's no air can blow into the cantilever and then blow through the floor and make the house cold. If you completely block and air seal the intersection between the cantilever and the rest of the floor, there's just nowhere for the air to go, so it's hard for the air to move through the small leaks that are going to be there. So that's a short story on those. And then for the insulation, just fill the cavity the whole way. Here's an example of someone sort of trying to block it, but they haven't spray foamed it or caulked it. And then on the right, they've got it all completely blocked off. A porch connection is kind of like that too. Sometimes framers will leave sheathing off where there's going to be a porch roof, but you really the best approach is to just run all the sheathing and air barrier stuff all the way down and attach the porch outside of that. Otherwise, you can have a really big connection that lets a lot of air through. Same thing here. Every once in a while you do find one of these things where the floor system cantilevers out over a porch. You're going to have to block off all those joist bays and air seal them. Okay, a couple quick things on walls. This is something that Energy Star came out with maybe 15 years ago, and I thought it was such a great idea. We've traditionally cut pieces of plywood or OSB to pack out headers so they're the full width of the wall, but that's like work. With a foam board, you cut it with a knife. Neither the plywood nor the foam board are doing any structural work, so you might as well use foam board. It costs the same, it insulates much better, and it's easier to work with, right? So you just use layers of foam board in between the pieces of the header. Or you can switch over to single ply headers, which are now in the code book, so there's charts for them. And then you have 1 ply of 2x material, and the rest of the wall is open. You fill that with insulation. So it's pretty easy to get a lot more insulation in a header than you might have thought. The other nice thing with using the single ply header, if you put it on the outside of the wall, then it's easy for the electricians to get wires back and forth. It's a pretty nice system. In corners, instead of nailing 3 2x4s together for a corner, you can just put 2, and then you can fit a little bit of insulation in there. Then you add a nailer for the drywall. So just leave an open space for the corner. These T connections that they've come up with is a pretty good idea. If you build either a ladder or, like in this lower illustration, you just add a single piece of 1x6 behind the 2x4 intersecting wall to catch the drywall. You can just fit the bats right around behind that. So you get full insulation, it's easy to air seal. That's a pretty good setup. Here on the left is the bad old way that I was taught how to do stuff. And on the right, the ladders that you'll be able to insulate behind. And then here on the right, you can use a 2x6 instead of a 1x6. If you don't have 2x6s, you don't have 1x on the job, use a 2x6. You can still get insulation behind. All right, any questions on the framing stuff? Okay. Okay. All right, so here are our keys. Let's do our framing so the insulation can be complete. Get the air barriers in place for the insulation. Help the installation crew manage a grade 1 installation. I mean, you'll have that thing, you can flip through it and say, no, 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 here's what we're doing. And if we're going to do spray foam, let's leave a couple days to do the quality check. All right. Yes, exactly. And seriously, don't go in there for 24 hours. It's one of the components of spray foam you can become sensitized to, and then you can never work on a job with polyurethane again. So it's really important to stay away from that stuff. Questions? Go ahead, Dave.
Yeah, so quick question. So you listed out some project manager keys. You just went through, 100 different items.
Roughly.
I would imagine that for the installation guys, it's really hard when we go through after they're done and point out a bunch of things and they've got to start pulling stuff down. Any recommendation for how the project manager should walk the installers through the key things that we're looking for? I know we have standards, but I can't imagine they cover the breadth of what you just talked about.
Dave's question is what's a good way to talk to the installers before they make mistakes so they don't have to come back and fix them later? That's one of the things I really love about this insulation booklet that we're handing out to everybody. It's not very long, and it has these, you saw a bunch of these pictures, bad, good, bad, good. So you can probably review all the keys to that in 5 minutes with a crew. If you're concerned about their quality level, it'd be very easy to do that. Spray foam's more complex. Of course, I'm more than willing and happy to come meet with people. I'm happy to come talk with spray foam crews or any other crew if that's helpful too. Good question.
And another recommendation just from DeVere is we have project managers that manage our crews as well. It might be a good idea if there's, if you're new working with DeVere, to connect with the project manager ahead of time, walk a project with him, at least the first project, so he understands that your standards as well, because he's going to be the one checking on the crews most likely.
That's a good idea. So have a pre-meeting with the supervisor and the crews. Yeah. All right, any other questions? Okay. All right, guys, thanks very much. Michelle, thank you very much. Really appreciate you coming in. That was very nice.